am Sri Jyoti. Welcome to my channel. Today's video is of conic sections part 3. So make sure that you have watched part 1 and part 2. In this video we are going to study ellipse. So what is an ellipse? See, ellipse is the set of all points in the plane and the sum of whose distances from the two fixed points in the plane is a constant. See, I will take. Let us take 3 points, any 3 points on the ellipse, P1, okay, P2 and P3, okay. So here, what is the ellipse? Ellipse is the set of all points in the plane, okay. The sum of whose distances from the two fixed points, okay, from the two fixed points is a constant. That means, see here, the distance of this plus distance of this, okay, that is equal to distance of this plus distance of this, okay. That is the sum of whose distances from the two fixed points in the plane is a constant, okay. Here also, so F1 P3 plus P3 F2 P3. So sum of, say this one F1, I will write here, okay. F1 P1, okay. F1 P1 means distance, okay. The distance F1 P1 plus F2 P1, okay. That should be equal to F1 P2 plus F2 P2 is equal to F1 P3 plus F2 P3, okay. That means, see, all these sum should be same in ellipse. That is the definition. That is the set of all points, okay, in which the set of all points in the plane, okay, and the sum of whose distances from the two fixed points is a constant. That means the sum of distances from the two fixed points is equal, okay. That is, see here, these 3 points, we have taken any 3 points on the ellipse P1, P2, P3, okay. So here F1, P1, okay, sum of these two, okay, sum of these distances, that is F1, P1 and F2, P1, okay, that is equal to F1, P2, sum of these distances, that is F1, P2 plus F2, P2, okay, that is equal to F1, P3 plus F2, P3, okay. That is the definition of ellipse. So from the definition of the ellipse, so we understood that there are two fixed points in the ellipse, focus 1 and focus 2, okay. So foci are there, two foci are there. So here let us see, there is an ellipse in xy plane and two points, fixed points, that is foci F1 and F2, okay. So let us take this distance be C, okay. And one more thing, see, this axis is called major axis and this axis is called minor axis, okay. It is major axis, okay. Now here we will take 2 points, okay, distance from the center, that is C, okay. That is center to F1 and center to F2, the distance is C, and this distance be B, okay, it is B, and here this one from center to this point, end point, that is A, okay. Now here let us join this one, okay, F1 to Q and F2 to Q, okay. We know that by the definition of ellipse, here F1Q plus F2Q, that is equal to F1P plus F2P. Why? Because P and Q are the points on the ellipse, right? So by the definition of ellipse, so what is the ellipse? See here, sum of the distances from the two fixed points is a constant, right? That is equal, right? So here F1Q plus F2Q, okay, Q is a point on the ellipse, okay. P is also a point on the ellipse. Therefore, by the definition of an ellipse, F1Q plus F2Q, that is equal to F1P plus F2P. Okay. Now let us find F1P plus F2P. See, F1P plus F2P. See here, F1P, how can we write F1P? F1P is nothing but F1O plus OP, right? OP, that is F1P is nothing but F1O plus OP, right? Plus F2P. See here, what is F1O? That distance is nothing but C. Okay, we have taken it as a C. Plus OP, that is A, right? It is, this distance is A. Plus F2P. What is F2P? See, this total distance is A and it is C. Therefore, this distance is nothing but A minus C, right? A minus C, because this total is A and this much is C. Therefore, it is nothing but A minus C. That is, here C cancelled. So, it is 2A. Okay. And let us find what is F1Q plus F2Q. See here, let us take this one. See, it is nothing but a right angle triangle, right? So here we have to find this side. We can find this side by the Pythagoras theorem. Okay, what is the Pythagoras theorem? See, B square plus C square is equal to this square, right? So this side square. So here we can find F1Q plus F2Q, that is equal to, see, it is nothing but by Pythagoras theorem, root of C square plus B square. Okay, it is also, okay, B square plus C square, whatever. Okay, so here we have got these two sides, right, by Pythagoras theorem, because see, if we consider this triangle, it is nothing but a right angle triangle, so that we can apply Pythagoras theorem to find the side. Okay, so F1Q, that is F1Q is nothing but square root of B square plus C square plus F2Q, that is square root of B square plus C square, that is 2 root of B square plus C square. Okay, so here we know that, as I mentioned before, see, by the definition of an ellipse, F1Q plus F2Q, that is equal to F1P plus F2P, because P and Q are on the points on the ellipse, right? So by the definition of ellipse, these sums are equal, right? That means F1P plus F2P, that is equal to F1Q plus F2Q. So we can write 2A is equal to 2 root B square plus C square. Okay, that implies A is equal to square root of B square plus C square. Okay, now see, we have got the relationship between A, B, C. Okay, that is A is equal to, or you can write A square is equal to, if you take square on both sides, A square is equal to, B square plus C square. B square plus C square. Next is eccentricity of the ellipse. See, what is an eccentricity of the ellipse? See here, eccentricity is nothing but, it is the ratio of the distances from the center to the one of the foci to the distances from the center to the one of the vertices. Okay, that is distance from the center to the one of the foci, any of the foci, okay, one of the foci to the distance from the center to the one of the vertices. See, these all are vertices. Okay, so one of the vertices. That means, see, this distance is nothing but C and this distance is nothing but A, right? Okay, therefore, eccentricity, and eccentricity is denoted by E is equal to C divided by A. Okay, so eccentricity is equal to, E is the ratio of the C to A, that is C divided by A. So here we have to find the equation of the ellipse, right? So here, to find the equation of the ellipse, we will have to derive the equations by the definition of the ellipse, using definition of the ellipse. So it will be a long derivation. So after the derivation, it will give us the equation of the ellipse x square by a square plus y square by b square is equal to 1. Okay, so after the derivation gives us x square by a square plus y square by b square is equal to 1. It comes from the definition of the ellipse. Okay, so here it is the equation of the ellipse. Remember, x square by a square plus y square by b square is equal to 1. See, it is the equation of the ellipse when the major axis of the ellipse is along with the x-axis. Okay, remember, if the major axis is along with the x-axis, the equation of the ellipse is x square by a square plus y square by b square is equal to 1. So, if in another case, if the ellipse major axis is along with y-axis, then x square by the equation of the ellipse is x square by b square plus y square by a square is equal to 1. It's replacing. Okay, that is x square by a square, b square plus y square by a square is equal to 1. So remember, if the major axis is along with the x-axis, the equation of the ellipse is x square by a square plus y square by b square is equal to 1. And if the major axis is along with y-axis, the equation of the ellipse is x square by b square plus y square by a square is equal to 1. Okay. Next, see, in parabola we have found the length of the lattice rectum, right? So here also length of lattice rectum we have to find. So here, what is the lattice rectum? See, here also lattice rectum is nothing but it is the line segment and perpendicular to the major axis, okay, and passes through the foci and end points on the ellipse, okay. So here two lattice rectums are there, okay, because two foci, so passing through two foci, so two lattice rectum. Let us find what is the length of the lattice rectum of the ellipse. Okay, so here let us take this point A, okay, and let this distance be L. Okay, here we are taking this distance as L. Okay, so here if this distance L, so what is the point, this point A? See here, it is the distance C, right? Since it is C, this distance is nothing but C. Therefore, x coordinate is C, right? X coordinate is C. And this distance is L, therefore y coordinate is L. Okay. And see here, we can write C as A into E, right? The E is equal to C by A, therefore C is equal to AE. So AEL is the point A. Okay. Now here, see, this point is on the ellipse, right? Okay. This point is AEL is on the ellipse. Since it is on the ellipse, this point should be satisfying this equation. Okay, why? Because the point lying on the ellipse. Okay, it's a point on the ellipse. Therefore, the point should be satisfying this equation. So here, substitute x is equal to AE and y is equal to L. That is, x is AE, so A square E square divided by A square plus y is L, so L square divided by B square is equal to 1. So here A square cancelled. So here L square by B square, take this E square right side. So 1 minus E square. This implies L square is equal to B square into 1 minus E square. Okay. Next, see here. What is E square? B square into 1 minus C square by A square. Okay, that is B square minus B square into A square minus C square divided by A square. Okay, so here, see, it is nothing but, see, what is A square minus C square? See, A square minus C square is nothing but B square, right? That is B square. See, just from the ellipse we have proved that from the derivation we got that is this one, right? This expression. We have got this expression a square minus c square is equal to b square. Okay. So here substitute a square minus c square as b square. Okay. So b square into b square divided by a square is equal to b raised to 4 by a square. So here we have got L square is equal to b raised to 4 by L square, a square. Okay. So what is L? So L is nothing but L square is equal to b raised to 4 by a square. So L is equal to b square by a. Okay. Understood, right? See this expression b square is equal to b square is equal to a square minus c square. This derivation we have already got from the first portion, right? From the definition of the ellipse. Okay. So here b square is equal to a square minus c square. Remember this one, don't forget it. See, we have to apply these things. This one, this expression. Okay. So b square is equal to a square minus c square. Okay, applied here b square into b square. So b raised to 4 by a square. So L square is equal to b raised to 4 by a square. Take root, square root. So L is equal to b square by a. So L is equal to b square by a. What is L? This length. So what is the total length? 2 into, right? Twice. So length of the lattice rectum length of the lattice rectum is equal to is equal to 2b square by a. Okay, so it is the length of the lattice rectum of the ellipse. So remember here no need of derivation, you just remember what is the length of the parabola, length of the lattice rectum of the parabola, length of the lattice rectum of the ellipse. Length of the lattice rectum of the ellipse is 2b square divided by a. See, length of the parabola, it was 4a, right? So here the length of the lattice rectum of the ellipse is 2b square by a. Now let us go through some questions. First question, find the coordinates of the foci, the vertices, the length of the major axis, the eccentricity and the length of the lattice rectum of the ellipse. Here equation of the ellipse is given. See, equation of the ellipse is x square by 36 plus y square by 16 is equal to 1. Okay. See, it is of the form x square by a square plus y square by b square is equal to 1. See, here it is the larger number. See, major axis will be large, right? So it is the a square. Okay, so x square by a square plus y square by b square is equal to 1. So here, first of all, we have to find the coordinates of the foci. See, here coordinates of the foci means these points, right? See here, this point is nothing but C0. Right? Because this point is on the x-axis, right? Since this point is on the x-axis, y coordinate value is 0, right? So here it is C0, it is minus C0. Okay. So here we have to find C, right? So here, let us see, here A is equal to, A square is equal to, compare, see first of all, comparing these equations with the standard equation, okay? Comparing this equation with the standard equation, x square by A square plus y square by b square is equal to 1. Okay. So from this we will get a square is equal to 36 and b square is equal to 16. That implies a is equal to 6, b is equal to 4. Okay. So here a is equal to 6, b is equal to 4. Now we have to find c. See, we know that the relationship between c, a, b, c, right? See, we derived it from the ellipse by the definition of the ellipse. Okay. So here c is equal to a square minus b square. Okay. C square is equal to a square minus c square b square. That is a square is 36 minus 16. That is 20. So this implies c is equal to root 20. Okay. Or root 20, or we can write 2 root 5. Right. Because 4 into 5, okay, so 4 root is 2 root 5. Okay, so here we have got a c value. So Let us write the coordinates of the foci. See, coordinates of the foci are C0. First C0, that is 2 root 5 0 and minus 2 root 5 0. Okay, these are the coordinates of the foci. Next, the vertices. Okay, coordinates of the vertices. See, vertices means these vertices. Okay, so here vertices here it is the length A, right? So this vertices is nothing but A0. Okay, it is nothing but minus A0. It is 0B, okay, because this point is on y-axis, therefore x coordinate 0. So this point is 0 minus B. So directly you can write what we know values of A, B. So here we can write the coordinates of the vertices are first A0, that is 6 0, okay, then minus 6 0, then 0 4, then 0 minus 4. Okay, these are the coordinates of the vertices. Next, the length of the major axis. See, very simple. We know that it is A, so total length is A plus A, 2A. So 2A, 2 into 6, that is 12 is the length of the major axis. Length of the major axis is 12. Next, the eccentricity. So what is eccentricity formula? E is equal to C by A, right? So E is equal to eccentricity. E is equal to C by A. That is, C is equal to, what is C? We have found already, yes, 2 root 5, okay. So 2 root 5 divided by 6, that is 2 3s are. So root 5 divided by 3 is the eccentricity. Okay. Next, length of the latus rectum. See, length of the latus rectum formula 2b square by A, right? So length of the latus rectum is 2b square by A, that is 2 into b square is 16 divided by A is 6. So here 2 3s are, so 16 divided by 3. So it is the length of the latus rectum.